Hey guys, today we're going to learn about the comparison test in the series of BC Calc or Calculus 2. So let's talk about comparison test. So the test itself means that if we have, let's say we have two series, AN and BN, and AN and BN both being greater than 0 for all n, and if BN is greater than or equal to AN, then if BN is convergent, AN is also convergent. And if AN is divergent, then BN is also divergent. So let me just quickly explain or reword this test, what this means. So we have two series, AN and BN. So to use this comparison test, we need two requirements. The first requirement is that both AN and BN, the series has to be, or this function or series has to be positive. It has to be positive. This is what it means by, I mean, you guys know, you should know this, but AN BN is greater than 0. So this AN and BN has to be positive. And number two, the second requirement is that BN is greater than or equal to AN. BN is greater than or equal to AN. So by meeting these two requirements, then we can say that BN is convergent, and if BN is convergent, then N is also convergent, and if AN is divergent, BN is also divergent. But keep in mind, after meeting this requirement, one thing you cannot do is going backwards. While we meet this requirement, we cannot say that if AN is convergent, then BN is convergent. That's false. We only can say if BN is convergent, AN is also convergent. We cannot go backwards, okay? Same as number two logic. So I'll use numbers or actual problem to sort of explain further for you guys to understand. So let's start with a really easy problem just for you guys to understand. Let's say, for example, AN equal to 1 goes to infinity, 1 over n to the fourth plus 33. I like 3. So this is given series, and the question asks converge or diverge. So what should we do? We should, first of all, set this given equation as AN. And now we have to find BN, right? And as a requirement, BN has to be greater than AN. BN has to be greater than AN. So let's see, I'll set BN as deriving from this AN equation. I'll say BN is equal to n to the fourth. How can we prove that BN is greater than AN? There you go, BN is greater than AN. So as you look at the fraction, I know you guys know this, but just in case, AN over A, if denominator is greater in fraction, I mean obviously the fraction gets smaller, right? So as you can see, I took out 33. So by taking out 33, denominator became smaller. That means the fraction itself, which is BN, got larger. Thus, we first met the requirement of BN is greater than AN. The second requirement is if AN and BN is both positive. Are they positive? The series starts with 1. So as we plug in 1, be positive all the time. And also because the n to the power is even number, even if we have negative, it still turns positive, so you don't need to worry about that. So let's start. So we say, I will write it down here, BN is equal to 1 to the n to the fourth, and AN is equal to, 1 over n to the fourth plus 33. We have to look at if BN is convergent, AN is also convergent, and AN is divergent, BN is also divergent. So can we tell BN is convergent? Yes, BN is convergent because due to the P series, because P is greater than 1, we can say that Bn is convergent. Sorry for being messy. And because Bn is convergent, we proved that Bn is convergent due to the theory, due to the test. I keep saying theory. So Bn is convergent, then also A is convergent. Thus, An is convergent. And our answer is convergent. So you guys get this, right? If you need help on the P series, I'm gonna soon post up the video, or there's video for it already, so you can take a look at that. And I will try another problem, a little bit harder than this. So another example, or another simple example to explain this concept will be n equals to 1 infinity, let's say 1 over n squared plus ln n, right? Ln scares you, right? I know. So we have this example of n over n squared plus ln. Like last time, we should set a n equal to 1 over n squared plus ln n. And now, what would be Bn? Like I said, in fraction, if numerator is bigger, then the fraction is bigger. If denominator is smaller, then fraction will be bigger, right? So I will make denominator smaller here. So if I take off ln, we'll get this, right? Because ln it is positive, should I say? It is positive function, because ln 1 will be approximately what? I mean, ln2, ln1 is 0, ln2 is approximately 0.7, I think, and it increases and increases and increases. So because it is a positive number from 1 to infinity, if we take this off, the denominator gets smaller and the fraction itself gets bigger, right? So we have proved that Bn is greater than or equal to maybe an. And let's see, is this a positive function? Is this positive function? Yes, because n squared always positive, ln always positive, right? Now we just need to prove if either an is divergent or bn is convergent, but because bn is much more simpler, we will work with bn again. So bn, is this convergent? Does this converge? I mean, yes, it converges, because due to P series test. Again, if you need information about P series, just try to go through the BC concepts in our website or in my YouTube channel. You'll find a video about it. So by being P greater than 1, which right now P is 2, so by P being greater than 1, it will be convergent. And by proving that Bn converges according to the P series, because Bn converges, An also converges. And this is our final answer. So in the problem, we just need to say C for converge. So thank you for watching, and for next video, I will upload practicing bunch of like other examples or problems using comparison test, and another video will talk about limit comparison test.